Hello and welcome. My name is Prasenjit Singh, and today I'll tell you about architectural diagrams, how to draw them, how to conceive architecture in the cloud, stuff like these. So, we all know that being a software engineer or a developer or a solutions architect requires technical communication to represent your ideas, and diagrams are the best ways to you can say one of the best ways to represent your ideas on paper, to explain others, and so on, to make your concepts clear, to understand how the entire thing is going to look like and work together. So the value of technical communication is not only reflected in the way that applications are developed through commercial products and open source projects and the way that business launch processes are accelerated, but its value is very much also reflected in experiences shared by different outstanding engineers in improving productivity, optimizing product performance, promoting the user experience, and so on. So, in order to explain our ideas and understand how different moving parts of an architecture would work and whether it would be successful or not, it is important to understand how to represent them as diagrams. So, to describe our system in one or more diagrams, we often encounter the following issues. One of them would be we do not know where to start. We do not know how to describe the system in one diagram that is clear enough for the relevant product, for operations and development teams to understand clearly. So, as an architect, halfway through, we realize we do not know who the audience is. We do not know if we are depicting a product functional chart, a technical diagram, or simply a mixture of both of these. So that becomes difficult in representing the architecture. And then when there are just a few boxes in the diagram, we do not know what more to add. We are never satisfied with the layout of our diagram. So if you all have run into the similar problems when trying to depict your architectural diagrams, this session will help you to understand what are the different options available to represent your architecture as a diagram and how to draw them and how to represent your ideas on a piece of paper. So, before we go on and understand more, let me tell you what is an architecture. Well, an architecture can be defined as an abstract description of entities in a system and also the relationships between them. It involves a series of decision making processes as well. So you can say the architecture is a structure and a vision. So it's a structure of different components, how they interact together in a system. So that is what we are trying to represent as a diagram now. So a system architecture is nothing but the embodiment of concepts and the distribution of correspondences between the functions and the things and the informations between these formal elements. It also defines the relationships amongst elements as well as between elements of surrounding environments. Like, say, you're drawing an architecture which involves a multi cloud. So, you would draw a system present in a current cloud, a system of servers present in another cloud or multi cloud environment. So, this representation is nothing but the architectural diagram. So, the architectural diagram is a diagram of a system which you can say is used to abstract the overall outline of the software system and the relationships, the constraints, and the boundaries between the components. It is an important tool that provides an overall view of the physical deployment and the software system. And it also allows you to understand the evolution roadmap of that particular architectural system. So, what are the functions of an architectural diagram? Why do we need that? Well, there are three main points around this. One is it allows you to break down communication barriers. People can understand the diagram and understand your architectural framework or your architecture that you have implemented or you intend to implement. Second is you can reach a consensus. Like, if you represent your architecture as a diagram, you can reach a consensus between different stakeholders who understand and agree with that diagram or do not agree. And it also allows you to decrease ambiguity. Everything is clear when represented as a diagram. So if you're just noting down or writing down the names of your servers, their sizes in a table, that doesn't give the complete picture how the servers would run, who is interacting with whom, and so on. But the diagram in turn tells you like what are the servers, what are the sizing, who interacts with whom, which one is on a private subnet, which was in a public subnet, and so on. So it gives you a complete flow, complete interaction, and complete description of the entire architecture. Well, now let's get down to business. So what are the different types in which we can represent our architectural diagrams? Well, diagrams can be classified into many categories. One popular type of diagram is the 4+1 view. This includes a scenario, a logical, physical, process, and development view of the architecture. So that is called a 4+1 view. So let me give you an example. What is a scenario view? Well, scenario view describes the relationships between system participants and the functional use cases and reflects the final requirements and the interaction design of the system. This view is generally a use case diagram. Now comes the logical view. Well, the logical view is used to describe the component relationships, the component constraints, the boundaries, the breakdown of system software functions. It reflects the overall system composition and how system is built. This view is generally a UML component diagram or a class diagram. So it tells you about the components and the relationships, constraints, and boundaries. So that is what it is. And then comes the physical view. This is a very common architectural diagram type. So physical view describes the mapping of system software and physical hardware and how system components are deployed, how they look like, and how they are deployed to a group of computable physical nodes. So it provides the guidance in the software system deployment process. So here you will see the real servers running, to whom they are connected to, what are the things around those servers, how they are distributed, and so on. So here you get a physical view of your infrastructure. Then there is another type that is called the process view. The process view describes the communication sequence and data input and output between system software components and reflects the functional data and data flows of the system. This view is normally presented as a sequence diagram or a flow chart. So this is how it looks like if you're looking at the diagram behind me. And then there is another type that is called the development view. Well, what is that? Development view is used to describe the division and the composition of the system modules and refines the compositional design of internal packages. Sounds difficult. Well, let me explain better. This view is normally a diagram that helps or allows developers to reflect the system development and implementation processes. So you understand what are the different components of the system or software and what component interacts with others and so on. For example, if you're writing a program to build a website that has multiple facets, like it has a payment gateway, it has a shopping cart, it has a page where the carousels are represented and so on. So these kind of development views give you an understanding of the entire software from the point of view of a developer, like which component will interact with what component, how will it hold up, what is the front end, what is the back end, what are the functions involved in there, and so on. Well, so the above five views that I discussed about, the five views that I discussed about, represent different characteristics of a software system from different perspectives. By combining them in an architectural blueprint, we can then describe the overall system architecture very, very clearly. So I hope by now you got an idea how the system architecture diagrams are done, what are the different types, You also came to understand that why architectural diagrams are important. See, these topics are not discussed at many places. No one ever discusses this, but this is what you need to know in order to be a good systems architect or a solutions architect or a cloud architect, or even a good developer. So very important to understand how to represent your thoughts into diagrams. So how to make the diagrams effective, how to make effective architectural diagrams. Well, how can we know that if a diagram is a good diagram, and what methods should be used to create such good diagrams? Well, uh, there are certain, you can say, conventions that we use to draw architectural diagrams. So we should know those conventions. So that would, applying those would result in drawing good architectural diagrams that should be consistent in structure, accurate to the data they are representing, and they should correspond to the code or the logic directly. So we have to know these conventions or the language of drawing these diagrams. So the first thing is using squares or blocks. So what do squares represent? Why don't we use circles instead of squares, and so on? Let's try to understand all that. The random use of squares or other shapes may cause confusion. So you should know what does it represent, what it is. So I'll come to that in a while. Similarly, we should know what dotted lines are for and what solid lines are for when connecting two squares or any two components in a architectural diagram. So that is also important. I'll come to that in a while as well. And then there are sometimes conflicts between runtime and compile time. Like building an architecture is a complex job. Therefore, using one diagram to represent the entire architecture is going to cause confusion. So you should be prepared or ready to understand how the different diagrams can represent the same architecture and when to represent which one. So these are the things you should understand. So how do we draw and how do we go about doing this and answer the questions related to the stuff that I discussed a while ago, like why squares, why not circles, and then when to use them, and why dotted lines and when, why solid lines and when, and so on. Well, the C4 model uses containers such as applications, data stores, microservices, as well as components and code to describe the static structure of a software system. These diagrams are easy to draw and their key elements are explicit. However, most important thing is that they clearly indicate the intended audience and significance of each diagram. The following example, which you can see now, is from the C4 website. On this basis, we managed to use our own understanding to better express the software architecture. So here in this diagram, you can see it's just like a block diagram, you can say, and it is a diagram of a planned banking system. It uses an external mainframe banking system to access customer accounts and transaction information and sends emails to customers through an external email system. As you can see, this diagram is simple and clear. It does not require any additional explanation for the audience to understand it. We can also see that it contains the system to be built, the customers of the system, and the peripheral systems that interact with this particular system. So these are simple block diagrams which can tell which type of system is to be built, who are the users, who will manipulate it, how it will be integrated to an existing IT environment, and the audience of this diagram can be anyone, like from the development team's internal staff, external technical staff, non-technical staff, and so on. It tells us what system is to be built, who will manipulate or change it, how it is integrated to the existing IT environment. So that is what these kind of diagrams explain. And how to depict this diagram when you're drawing such a type of a C4 diagram, then your own system should be depicted in the middle of the diagram, and the users and the systems that interact with are placed around it. And the key aspect of this kind of a diagram is that it organizes and clearly shows the user's high level dependencies of the system to be built. And after the conceptual work is done, it takes a few minutes to depict the diagram. It's very easy. Just understand how the system works, what is the core component of the system, put it down in the middle. What are the other parts that interact with the core? Put it down around it. Connect it with dotted lines or arrows depicting the flow. That's it. You're done. And label the diagram well. So that is one kind. And second type is called a container diagram. Now, the container diagram expands the system in the previous system context diagram. So what it is? Well, if you can look at the diagram now, in addition to the users and peripheral systems, the system to be built includes a web application based on a Java Spring MVC architecture to provide a functional portal for the system, while a mobile app based on Xamarin provides a functional portal for mobile clients. The Java-based API application provides services, and we have a MySQL database used for storage. Now, you will see that the arrows indicate interactions between applications. If they are double-headed arrows, interaction is both ways. Single-headed interaction is on one direction, unidirectional. And when you look at this diagram, you will not notice whether the boxes have sharp or rounded corners, or whether the arrows have solid or dotted lines. Even the directions of arrows do not attract much attention in this diagram. So there are many drawing methods, in fact, all of which define meanings of frames and lines. This requires both the drafter and the viewer of the diagram to clearly understand these conventions or definitions. Only then all the information of the diagram can be understood. However, you can also put a legend describing what your dotted lines means, what your solid line means, and so on. However, this is demanding, and many viewers will only catch the general concepts. So, but it anyway describes your concepts in a better way. So what does this kind of a diagram depict? It presents the overall structure of the software system. It reflects a high level technical decision making. It shows how responsibilities are distributed in the system and how different parts or containers interact with each other. And it also tells the developers where code programming is required, what stack is being used, what software stack, Java, Python, or whatever is used at what stage and at what container level. So that is what is depicted. Now, this diagram uses frames, as you may have seen, and this may include names, technical choices, responsibilities, and interactions between these frames. If an external system is involved, it is best to define the boundary. So you can see the square or rectangular boundaries, dotted lines. So it defines the boundaries of a system. Very important when you are having a large scale complex system. So it can be many systems within a system. So you put those boundaries. For example, when we draw network diagrams that depict different subnets for a cloud architecture, we create VPCs, subnets in different rectangular boxes, and within it we define the servers or network devices that are present inside that particular boundary. So that is how it is. Now comes the component diagram. Well, the component diagram, as you can see, is used to expand a container and describes its internal modules. Now, if you want to focus or zoom in on one particular part of the system, so that is what you see as a component diagram. So what is the use of these kind of diagrams? It is intended for internal developers and shows them how to organize and develop code. The diagram serves a lot of purposes, like understanding the relationships and dependencies between components, and shows how your development tasks can be distributed and delivered. Now, let's get down into a bit of a software developer level, where we draw certain diagrams to understand how the software is developed. So we call that code or class diagram. This is how it looks like. Now, this diagram is intended for the technical staff, developers, support staff, and it's a common type of a diagram which represents the class and the code. Well, now we have another diagram type. Well, this one, as you can see, is an internal real-time data tool. As an architectural diagram should be self-evident, you can see here in this diagram, there is not much need for explanation. If you pause this video and look at the diagram for a while and then come back, you will know what this diagram is meant for, what system it is trying to depict. And remember one thing, if you cannot clearly understand what a diagram depicts, then it is not a good diagram. So one should do or draw a diagram that should give a good overview of any technical architecture. So as you have seen, there are many methodologies for depicting a good architectural diagram. You know how the block diagram was, what is the C4 method, and so on. So now you can use this knowledge to try to draw your diagrams, study about the conventions. As I said, if you are drawing rectangles, you're defining smaller components. If you're using a cylinder, maybe that represent a database. Different network devices have different icons. Like you might have seen, routers would be a circle with arrows, and similarly switches and gateways and so on. So you will have to learn different conventions that allow you to create your diagrams. You have to learn different symbols, and also know, as I said about the arrows, solid line would represent coupled architecture between those two components. If there are dotted lines, there are interactions, but it is not consistent or coupled. So probably asynchronous communication and so on. You can also represent these in the legend, what you mean to express in that diagram if it is not evident. And then apart from the flows, you will draw system boundaries to understand what particular system is, and how it is separated from the other parts of that system. And if there are subsystems, you again draw them. And if you want to explain a particular subsystem, again you zoom in and draw the component level diagram as well. So search for the C4 method, Google it, and learn more about it. If you have questions, just ask me in the comment section. I would be happy to share more tips on how to understand system architecture and draw architectural diagrams. This is just a beginning because no one shares much about architectural diagrams. I thought, why not do this? Because I haven't seen a video explaining system or solutions architecture as diagrams. Thank you. See you around.